Okay, let's talk about section 1 of chapter 2. We're going to talk about lines first. So this should be something you already know. Slope, we're going to use slope to graph these lines. We're going to find the slope between 2 points, write equations giving 2 points, identify parallel and perpendicular lines, all stuff that you've done before. So let's start with slope-intercept form. Slope-intercept form is y equals mx plus b, where m is the slope, b is the y-intercept. I'm going to go quicker through this because of the fact that you've learned this for 3 years. This is your 4th year now learning slope-intercept form, maybe 5th year. Probably learned this in middle school for the first time. So let's move on then. I know you can sketch a graph of these. I would hope to graph this, the slope is 2, the y-intercept is 1. So quickly, here's the graph. This has a slope of 2 and a y-intercept of 1. So it goes through 1 and goes up 2 over 1, up 2 over 1, up 2 over 1. Hopefully you guys know how to do that. Slope is just, if you recall, rise over run. So if this slope is 2 over 1 in this case, that means you go up 2 over 1. Okay? This line now in red will be this one, y equals 2. Y equals 2 is this line. X can be anything, but y always has to be 2. X changes. X can be any value you want, but y is stuck at 2. Okay? And then this equation is in standard form. The best way to graph an equation in standard form you learned was to plug in 2 points. Plug in 0 for x, and you get y equals 2. Plug in 0 for y, and you get x equals 2. So the point 0, 2 is here. The point 2, 0 is here. And then 2 points determine a line. So this is the third one. You also could, if you wanted to, subtract x from both sides, in which case you get y equals negative x plus 2. And that's a line that has a y-intercept of 2 and a slope of down 1 over 1. Down 1 over 1, down 1 over 1, slope of negative 1. So those are just sketches of the lines. Hopefully you guys are comfortable with that. So slope is, like I said, slope is rise over run. So rise is going to be the difference in the y-coordinates. Run is going to be the difference in the x-coordinates. Okay. It doesn't work for vertical lines because in a vertical line, there is no change of x. So in a vertical line, you have a run of 0, which is undefined. So obviously we can't divide by 0, so our vertical lines have an undefined slope. Okay. Let's try a couple examples then. Let's find the slope of a line passing through these 2 points. Let's do y2 minus y1. 1 minus 0 over x2 minus x1. 3 minus negative 2. And that gives you 1 over 5. So the slope of the first one's 1/5. Next one, y2 minus y1 over x2 minus x1 should give you 0 over 3, which is just 0. The second one has a slope of 0, so it's horizontal. And part 1a had a slope of 1/5, which means it goes up 1 over 5, so it's going to be a line, the slope anyway will be, pretty narrow. It only goes up 1 for every run of 5. So it's pretty, not very steep line. Okay, so we can write a line in point slope form. Y minus y1 equals m times x minus x1. I can put this on the formula sheet if you want, but this is going to be a handy equation to use if you're given a point and slope, for example. Basically, anytime we write an equation of a line through 2 points, we're going to want to use this as well. So let's try an example. Here's we want to use point slope form to write an equation of a line that has a slope of 3 and passes through the point 1, negative 2. So I'm going to write that down first. Y minus y1 equals m times x minus x1. So y minus y1 is negative 2. Slope is 3. And x1 is 1. So you have y plus 2 equals 3x minus 3. And then subtract 2 from both sides. You get y equals 3x minus 5. This is in slope-intercept form. And if this, I could leave it just like this. It did want us to put it in slope-intercept form, but this is also an equation of a line. This happens to be in point-slope form. So this is point-slope. and this is slope-intercept. Okay, let's keep going then. All right, so parallel and perpendicular lines. Parallel lines have the same slope, and perpendicular lines have opposite reciprocal slope. So you can see that for this right here means you're going to reciprocate whatever slope you have. So let's say m1 is 2. All right, so opposite reciprocal slope means you're going to reciprocate it. So you're going to take 2 over 1 and make it 1 over 2. You're also going to multiply by a negative 1. So if you have a slope of 2 over 1, the opposite reciprocal of that, opposite means you change the sign. Reciprocal means you flip the numerator and the denominator. Okay? All right, let's try another example then. Let's find slope-intercept forms of the equation of lines that pass through this point and parallel to this line. Okay? So for part A, I want to find out what the slope of this line is. There's different ways to do it, but I like to, when I'm trying to find the slope of a line in standard form, I like to solve for y, put it in slope-intercept form. If I solve for y, I would subtract 2x from both sides. This gives me negative 3y equals negative 2x plus 5. And then divide through by negative 3. Don't forget to divide everything through by negative 3. Okay? Then I've got the line, double negatives go positive, so those are going to be positive. I can move this negative up to the numerator up here, from the denominator here. So I've got this in y equals mx plus b form now, where the slope I can see is 2/3. So I know if I want a parallel line, I'm going to write this equation in point-slope form, and then I'll move it to slope-intercept. There's different ways to do this, but this is the way, I guess, this is probably the easiest. The slope I want to be 2/3, and the point I want to go through is 2, 1, so it's x minus 2 for x1, and y minus negative 1 for y1. So this becomes y plus 1 equals, I'm going to distribute 2/3 x minus 4/3. Just distribute this 2/3 of both. Now I'm going to subtract 1 from both sides. Subtracting 1 is the same thing as subtracting 3 over 3. I multiply the top and the bottom of 1 by 3 so that I can get a common denominator. So negative 4 minus 3 gives you negative 7. So this becomes negative 7/3. So here's the equation in slope-intercept form, which is what they wanted for part A. Okay. Now for part B, they want perpendicular to this line. So a perpendicular slope now is not going to have a slope of 2/3, it's going to have a slope of negative 3/2. So that's going to simplify to be a different equation. I plug in the same x1, y1 for my point, but the slope is going to be opposite reciprocal to 2/3, so negative 3/2. Okay? If I distribute that, this becomes negative 3/2 x plus 3, if I distribute. And this is y plus 1. So I'm going to subtract 1 from both sides. When I subtract 1, 3 minus 1 is 2. So this becomes my equation right here for part B of a line perpendicular to this line through this point. Okay, some applications, real-life problems. This actually has a ton of application because anytime there's a rate of change, we can use slope. Okay, calculus, a huge part of calculus is rate of change. The definition of derivative involves slope. Definition of derivative really is slope. The biggest part of Calc 1 that you learn about is slope. Okay, if the x-axis and y-axis have the same unit of measure, then the slope has no units and is a ratio. Okay, if the x and y-axis have different units of measure, then the slope is a rate or a rate of change. So let's look at an application problem then. The maximum recommended slope of wheelchair ramp is 1/12. If business is installing a wheelchair ramp that rises 22 inches over a horizontal length of 22 feet, is the ramp steeper than recommended? Okay, so let's take a look. We need a slope of 1/12. We need a rise of 1 to 12. Well, this ramp rises 22 inches to 24 feet. Now, as of right now, I've got a ratio. I don't have a rate of change. I have a ratio because I'm comparing two quantities, inches to feet. I need to get a rate of change when you compare the same quantity, up 4 inches to every 5 inches that you run or something like that. I need to get the same units. So let's go to inches. Let's multiply feet in the bottom here. There's 12 inches. in 1 foot. So I'm just going to convert the bottom. Alright, so I'm just doing this separate. What I'm doing is I'm converting this 24 feet to inches. So I'm going to multiply by 12 inches is equivalent to 1 foot because I'm multiplying by 1. These are equal, so this is just 1. And that way the feet cancel, and I just have it rearranged as 288 inches. So this ratio now becomes 22 inches to 288 inches. Now I'm comparing, now I have a rate of change. Now I have, I'm comparing two quantities, 22 to 288. I need to figure out what is that in comparison to 112. Is it steeper than 112? Is it the same as 112? So what you could do is divide both of these and get a decimal, I guess. Or you could try to simplify this and get 1 in the numerator. Let's see. What you can do is get a 1 in the numerator here, so divide the top by 22 and divide the bottom by 22. Obviously you have to do it to both. And this gives you 1 to 13.09. You know, and the other, this recommended slope, or the required slope for a wheelchair ramp, if you don't want to get sued as a business, is 1 to 12 for Americans with Disabilities Act. So we have 1 to 13. So we go up 1 and rise. So this isn't steep enough, basically. Up, it runs for every 1 that goes up, it runs 13.09. So the slope would be like that, as opposed to the recommended is 1 to 12, which is a little bit steep. And I don't think you get in trouble for not having steep enough, but yeah. The slope of this ramp is 1 to 13.09. So to summarize, we have general form of a line, which is AX plus BY. I usually say equals C. So I usually say AX plus BY equals C. So move C to the other side. Vertical lines have the form X equals a number, because Y can, for a vertical line, X always equals a number, but Y can be anything. So X equals 4, for example, and Y can be anything. Horizontal lines have the equation Y equals a number, like Y equals 2, for example. Y equals 2, X can be anything, but Y always has to be 2. Slope-intercept form, you know, is Y equals mx plus b. Point-slope form, Y minus Y1 equals slope times X minus X1. And then this is just two-point form, which we won't use, but it's basically just all they do is plug in slope, which is the difference to Y's and the difference to the X's. So I'll give you any of these equations you want on your formula sheet, that's fine, but you might have most of them memorized from using them for the last 5 years. Okay, hope this helps.